Thank you. So please start, sir.
Yeah, good afternoon to all participants. I am Dr. K Shukla, presently serving as Director, ICAR Central Institute for Research on Cotton Technology, Mumbai. It is also situated in Nagpur. And our institute is a premier institute working in the area of post-harvest processing of cotton and value addition. And our institute is 100 years old. We are celebrating our centenary year. So we have presence across the India. In the northern area, we have our presence at Sirsa. In central India, we are present in Mumbai, Nagpur, Surat. And in southern India, we have presence in Dharwad, Guntur, and Coimbatore. So our topic has been allotted is value addition of agro residues, particularly to the cotton biomass. So I will focus on that. I will focus on value addition of biomass for the preparation of briquettes and pellets, where we will, because these are the only two products which are running in the industry and has a commercial viability. So just a small thing that how biomasses have different this calorific value. If we see that cotton stalks, rice husk, and if we see these two products, cotton stalks is more or less similar to this sawdust, as well as it is very much similar to coal, and it has very low ash content. If we compare to the coal has ash content ranging from 20 to 40%, but our most of the biomasses have very low ash content. So it is preferable material if it is available for the value addition to the agro industry. Now coming to the what are the products possible from agro residues. We can make good quality briquettes, pellets. We can also make particle boards. We can grow mushroom over the biomasses. We can convert the biomasses into charcoal, and we can do the composting of these biomasses. But my presentation will be totally dealing with briquetting and pelleting. If any participant is interested to know the technologies about other products, we can take it up later. Now coming that how the briquetting and pelleting plant looks like. Briquetting machine is seen in our left side. There is only one machine, big machine is there, and it gives around 2 ton per hour capacity. Normally in the factory, they are going for 2 or 3 machine in a series so that they can produce more briquettes using same infrastructure facility. Pelleting machine, which you am showing, it is a small capacity machine. It can be used for rural areas, but for commercial viable plant, we will show that how the commercial viable plant is working presently in the industry. The briquettes, as we know, it's around 90 mm diameter, and it has around 1000 to 1200 kg per cubic meter bulk density. And it is used by one piston press system, which is very popular in India. And it's a very simple and easy process. There is no need for any binding material for making the briquettes. There is already natural binder, that is lignin, is available in the biomass. When it is pressed, it is heated up around 100 degrees Celsius temperature. That heating itself make these particles bind together. These are used in different applications. So it is very difficult to name all the application. I can say only one thing. Wherever there is heating, requirement of heating, the briquettes and pellets can be used, particularly in the boilers, force, cleans, gasification system. These are the system where briquettes and pellets are being used. Now coming to the flow chart, how briquetting plant works. So first, this material has to be chipped to small sizes, around 10 to 15 mm sizes, and after chipping, it has to be fed through manual system or tractor feeding system through a screw conveyor. A screw conveyor is seen here. After a screw conveyor, it will be coming to the briquetting machine, which is displayed at the center. Briquetting machine is a piston type pressing machine. Then briquettes will be coming out like this from the end of the machine, and it will be packed in gunny bags or plastic PP bags and supplied to the end user. This is the how much power requirement is there. There is around 90 SP power requirement for operation of a briquetting plant. Its productivity is around 1 to 2 ton per hour capacity, and there is requirement of 4 manpower for feeding and for heating the material, and 2 manpower for feeding. So 6 manpower is required to operate a commercial briquetting plant. And if we consider that how much infrastructure is required for establishment of one briquetting plant, the area requirement is where 2 acre land, and the machinery cost is around 25 lakh rupees, but total investment will be to the tune of around 1.25 crore rupees, 125 lakh, because it includes the civil infrastructure, electrical connections, firefighting system, all those things are cost heavy. That's why the briquetting plant, they are going for multiple briquetting machines, 2 or 3 machines, because rest of the prices remain same. Only machine price 25 lakh is added, but your capacity is double and triple, so that your plant become viable. So operation cost for running of a briquetting plant is around 600 rupees per ton, and this energy requirement is 35 units per hour. And but maintenance cost, because it's a high pressure system, RAM is always goes out of order after a particular period of time. So its requirement around 75 rupees per ton is the total maintenance cost. Okay, now coming to the pelleting plant. Pelleting plant is slightly having more advanced machinery and more number of machines as compared to briquetting plant. Briquetting plant, as we have seen, only one machine is enough to make briquette. But for pelleting, we require a series of machines. Here, difference in the briquette and pellet is briquette is 90 mm size and pellet is 6 to 10 mm size, and it has high bulk density of around 600 kg per cubic meter. And there are 2 types of pellets which are required in the market. Left side figure shows it is a non-torrefied material, and right side figure shows it is torrefied material. So these two, the 99% of India's pelleting products are made of non-torrefied material. Non-torrefied material. Torrefied material, we are attempting it, but a very limited success has been achieved in this direction. If we see that how the pellet requirement is increasing year by year, if we see that in 2000 the requirement was less than 5 ton requirement, but less than 5 million ton requirement, but currently it has increased to around 45 million ton requirement. And most of the consumer, if we look into here, are the European nations and American countries, South America, North America, even Asia, but it is apart from China. If we consider the China is producing to the tune of 20 million metric ton per year. So if we can see that every year the requirement of pelleting is increasing, because it actually reduces your dependence upon fossil fuels, and because of global warming problem, people are promoting such type of business. And in India also, this pelleting plant has increased multifold in last 3 years, because government of India has also come out a policy where it has been made mandatory to use 5% pellets in the co-firing of boilers. And it was implemented last year compulsorily, but because of less availability of pellets, it has been delayed by 1 year. Hopefully, this October it will be made mandatory. Currently, there is requirement of around 5 lakh ton, 6 lakh ton per day for the all power generating unit. But our production is limited to 1 lakh ton, 2 lakh ton like that. So slowly production is increasing, and one day government will make it mandatory. And our target is that in the future coming years, the 2 years, it will be increased to 7% more. So it will become 12%. In that case, requirement will be almost double or 3 times. So this industry is going to flourish, and a large number of biomasses would be utilized in making the pellets. Now coming that, what are the this requirement for establishing a pelleting plant? There are three technologies which are in use. One is the standalone flat die pelletizer system, which is shown at the left side. In which the central portion here, dual feed briquette machine. Here, briquette machine is used for pelleting. Here, only changes which has been made, that die from 90 has been converted to 6 to 8 12, 20 actually, in fact, because 20 they are keeping because it is requirement of power plant industry. So this machine is costing 20 lakh rupees, but other cost also will be coming into play. And third, which is a commercially available pelleting plant, is the ring die pelletization system. This is the only plant which is used worldwide, like in European country, North America, South America, Brazil, China. Ring die type of machine is there. Our maximum capacity of pelleting machine at present in India is 2 TPH only. But foreign countries, European, they are going for 5 million metric ton, 10 million, 5 ton per hour, 10 ton per hour capacity they are going. And their cost of the investment is also very high as compared to ours. Now coming that standalone is, if we are going for this system, investment will be around 10 lakh rupees for machinery, and equal amount will be required for other infrastructure. And we can say that in 25 lakh rupees, you can establish this type of standalone system. But it is very difficult to operate because 2-3 levels required to continuously feed the material, and you are getting less output also, and your manufacturing cost is almost double here, 3,500 to 4,000 rupees per ton. So if somebody is getting a price of pellet for rupees 10,000 rupees per ton, then only it is feasible. Otherwise, it is not feasible. It is used for a special purpose applications like cooking stoves, where 6 pellets are needed, and where ash content requirement is less than 5%. Those places, such type of machines are being used, and it being supplied to the these type of customers. A small video is there. How does it work?
Sir, we can't hear any audio, sir. As the video is playing, can you just explain, sir?
Here biomass is fed here. It will be going to this pelleting unit through vertical screw conveyor system. It is coming to flat die system, and from flat die system, pellets are being formed, and whatever fines are there, those fines are segregated. This is complete pellets made using this machine. This is the commercial plant established in Nagpur, MIDC. This is another example that how pelletizers work. I think video is more or less remain same, so I will not play this video. Now coming to the total investment, as already I have told, around 25 lakh rupees investment is required for establishment of this plant. Here land will be half acre. You require around 1,000 square feet building, and material storage also require 500 square meter. Office building 50 square meter. The total investment will be around 25 lakh rupees. And but rate of return is 26% only. So payback period will be around 4 years. Now coming to the viable commercial size plant. Here, as already we have discussed, that it requires a line of machinery. We can see here the first machine which requires drum chipper. This chipper is meant for reducing the material to the 10 to 40 thickness size. Then it will go to the hammer mill, which actually hammers the material and converts this material, this 10 to 40 material to 3 to 8 material sizes. Then it will be coming to sieving machine for 3 to sieving, depending upon the diameter of the pellet which you are making. After sieving, it will be going to the bucket elevator. After bucket elevator, it will be coming to the feed mill tower, having dosing system. Then it will be again coming to a screw conveyor system. Finally, pellet, it will be coming to the pellet mill having capacity of 1 to 2 ton per hour size, and then it will be coming to belt conveyor system. Finally, it will be going to vibro sieving system where fine material will be segregated and pellets will be separated and it will be packed. This is complete line of the machinery. Sometimes we require a dryer also. For that, additional 45 lakh rupees investment is needed. These are the pictures of these machines. Drum chipper is shown here. Rotary drum dryer is here, and this is a feeder machine, and it is coming. This is spooler machine. This is a pelleting mill, and magnetic separator is also required for separation of any metal particles. Now coming that how much investment is required for establishing this type of facility. For that, minimum 2 acre land is needed. Shed area requirement is 10,000 square feet. This is bare minimum I'm telling, but actual plant they are going for shed around 15,000 square feet also. Capacity requirement is 2 TPS. Minimum one should go for 2 TPS. Less than 2 TPS it is not viable. And budget is around 5 crore rupees. And if in that you require raw material of worth 25 to 30 lakh per month for feeding to the plant of capacity 2 ton per hour. So here you can calculate how much is the working capital requirement. Production cost will be around 2,500 rupees per ton, and selling price should not be less than 8,500 rupees per ton for making this plant viable. Earlier, we said that 6,500 to 8,000 is also viable, but currently biomass prices have increased in the market. They are available in not less than 3,500 rupees per ton with also 15 to 20% moisture. So after reducing the moisture, the cost becomes of biomass around 4,000 to 4,500 rupees per ton. Then 2,300 to 2,500 will be your production cost. It comes to around 7,000 rupees, 7,500 rupees per ton. So you should get minimum 1,000 to 1,500 rupees per ton as a profit to make this plant a commercially viable plant. And one more thing has to be noted, during the rainy season, it is very difficult to get raw material. So most of the entrepreneurs, they are arranging material for 4 month duration during the raining period. For that, they are investing around 1 crore rupees in the storage of the material. These are the different suppliers of the machinery. RK Machines, Gujarat, there are only 3 manufacturers in India who are making this type of machine. One is the RK Machines, Halol, Vadodara, Gujarat, it is there. Another one also is RK only. This is RK Biofeed Machines. These two are the standard supplier. 99% plant I have seen which are employing these machinery of these two manufacturers. One more is there Hindustan Equipment Private Limited. This is in Indore. And for small pelleting plants in Nagpur, one party is there, Vidarbha says, they are marketing. There are few more also, and Raghavan Industry is also there, but they are actually masters in flat die system, not the ring die system. This is the operation of a commercial size pelleting plant. If I can show video. This is pelleting machine. Material is fed from here. Material is fed from here bucket elevator. It will be coming to hammer mill. From hammer mill, it will be coming to another set of machinery. And finally, after once pellet is made, it will be coming to the packaging material, and material will be stored in a PP bag. And once it is stored, it will be of a particular quantity. It will be coming to weighing system where it will be weighed and it will be packed. This is the, now you can see that how pellets are coming to belt conveyor system. It is going. Now we can see that what are the mandatory protocol for successful operation of a commercial pelleting plant. So I can take one by one. First important thing is that biomass must be screened to appropriate size. For that, sieving is very good sieving is required. Suppose someone is making pellets of 6 mm. For that, maximum 3 to 3.5 mm size material should go, not more than that. If somebody is making 8 mm, then maximum 5 mm material should pass. If oversized materials are there, it is going to choke your pelleting plant. Second thing, moisture shall be around 15 to 16%. If moisture is less, then more fines will be there and making pellets will be difficult. If moisture is more, pelleting the pellets which are going to be made of less strength. That is also not accepted by the industry. And the one thing is notice that if mixing is not proper, then pelleting machine is not going to work properly. Mixing, I mean to say that this if you are pouring water, normally biomass is coming with 8 to 10% moisture content. Then you have to mix water to make it 15 to 16%. If mixing is not done properly, somewhere it is dry material, somewhere wet material, it is going to hamper the operation of your plant. And second thing that some users are some biomass pellet manufacturers, they are going for binders. If binders you are adding, that should be also mixed thoroughly and properly, preferably using tractor loader system. If somebody is using manual system, it is very difficult to properly mix it. Now coming that what are the binders which are used in the market? There are particularly different binding agents which are used, like bamboo seeds are used. It is available as rupees 5,500 per ton. Tamarind seeds are also used. This is also purchased at the price of rupees 5,500 per ton. Sal seed DOC, it is very popular in the market. It is available at the rate of 7,500 rupees per ton. It is required only 5%. If binder is enough, 5% binder is enough. But nowadays, pelleting plant industry is not getting sufficient binding material. So they are mostly making pellets without any binding material. If binding material is well and good, it will give lustrous color to our pellets and the fines will be less as well as strength of the pellets will be more. But if binder is not there, then these some problems will arise, but still people are able to make it. Now these are the biomasses available particularly in Maharashtra state. Cotton starch is there, soybean is there, makka is there, groundnut cells can be used, bagasse can be used, sawdust also can be used, wood chips which are base material that also used, rice husk also people are using, paddy straw also people can use it. Now there are some certain issues in supply of different biomasses and like somebody is using cotton stock. So cotton stock supply is only available for a particular period of time. It is available for only 2 to 3 months period. And if it is available for 2 to 3 month period means you should have a proper collection system. And many times if it is not shipped properly, it will cause the shortage of indie also. And people are reporting that if it is used exclusively for boiler firing, it is causing slagging and fouling of the boilers. That needs to be also addressed. That means if you are using cotton stock, you should mix some amount of other material also. Suppose cotton stock is used 30 to 40%, there is no problem. If you are 100% cotton stock is used, the end user may complain about boiling and fouling up in the boiler. And it's as containing 6 to 8%, calorific value is very good. And it can be arranged at around rupees 3,000 rupees per ton. Now coming to the soybean is abundantly available in the market. There is no need for collection of this material because while harvesting itself, biomass is also harvested. So it is available, but only problem is that here ash content is coming slightly on higher side, around 15 to 20%, because lot of soil content is also added while storage as well as while scooping the material. That's why one has to be careful that if your terms of supply is less than 15%, you will have to add other material also. It has calorific value around 3,500. It is particularly in Maharashtra, wherever cotton stock is cultivated, soybean is cultivated. It is available at rupees 2,000 per ton within 50 kilometer of supply. Now, coming to the sawdust, sawdust is a very costly material because it has very less ash content, around 4%. Calorific value is very high, around 4,200 per kilocalorie. And it is mostly available at the price of 3,500 rupees per ton with 30% moisture. After reduction of moisture to 8 to 10%, the cost becomes 4,500. It is a cost, the cost which I am showing you, it is 1 year ago cost. Presently, it has increased by 1,000 rupees. So it is coming to around 5,500 rupees per ton. So if you are getting order of 9,000 to 10,000 rupees per ton, then one should use the exclusive sawdust. Otherwise, you have to mix it with other material to make it commercially viable. Rice husk problem is that it has very high ash content, 22 to 29%, sometimes it is 30%. Here silica is very high, 92 to 95%. Silica causes lot of problem in operation of the boiler. It actually causes the erosion of the metal material. That's why if somebody is supplying 100% rice husk, it may not be accepted by the industry. So we have to be doubly sure that if somebody desires, then only it can be used. Otherwise, you can use it to 5%, 10% level. This now coming to the bamboo, wherever bamboo cultivation is there, bamboo can also be used. And good thing is that bamboo has very high calorific value, around 5,500 rupees per ton. Ice content is also 2 to 3%. If bamboo is available, it can in nearby area, it can be also used as a good source. It can be mixed along with poor quality material like soybean and all to make a good quality pellet. These are these biomass pellets which we developed in our research unit by mixing different materials. So now we can see that what are the quality of the pellets being set by international organizations. It is a Pellet Fuel Institute, Seattle, USA. They have set the pellets quality standards. Here bulk density should be around 600 kg per cubic meter. It is achievable. It's not a problem. We can very easily achieve in almost all the material if we are using optimum moisture content and some binding material. Diameter of pellets they have used around 6 mm sizes. It is also achievable, not impracticable. Now, another term is pellet durability index. It is popularly called as PDI. It requires 95% and above. This is also achievable. Fines should be less than 1%. It is also achievable. It's not a problem. Only thing is that inorganic ash content, which they are citing here, less than 1%, less than 2%, and less than 6% for different class of the material. These qualities are very difficult to achieve in the biomasses, unless otherwise we are using sawdust in this. Other properties like moisture content and length of the material, these things are also achievable. Only they are citing one more value, that is fluoride content. Fluoride content should be less than equal to 300 ppm. It is not possible if we are going for making the pellets from biomasses, because chloride and fluoride content as well as silica content are bit higher side than recommended by PFI. But good thing is that our this power generation units, they are not seeking these things, fluoride content and other things. These first 4-5 information is enough. Ice content also up to 20% is allowed as per the Indian standard, what they have published by Biomass Mission. So pellet, but international supply we have to check it. These are the European pellet standards are also very tough, not easy to achievable. They are asking less than 1% ice content, which is impossible in any biomass. This is the standard which is set by Ministry of Power. Here the standard suggests that the pellet diameter can be up to 25 mm and length can be up to 50 mm. Density should not be less than 600 kg per cubic meter. Fines should be equal to or less than 5%. And for GCV, gross calorific value, for non-torrefied material which we are discussing, it should be 3500 plus minus 100. Moisture should not be more than 9%. Ice content should not be less than 20%. And SGI values, they are telling hydrogroup grindability index 50 or more. So these conditions are set considering our capability and our aim, because our aim is the utilization of biomass. But European Union and American countries, what are they doing? They are promoting the preparation of pellets from wood waste. So they are growing woods for such purposes and cutting the woods and then using it so that they are able to reduce the ice content to 1% level. But it is not feasible in our condition if we are using biomasses. These are the different equipment used for measuring the different quality characteristics, like muffle furnace is used for moisture calculation. Bum calorimeter is used for gross calorific value calculation, and pellet durability index tester our CIRCOT has developed, and bulk density measurer also a standard is there, that how does it work. And these are the different pellets we have developed from different biomasses. Thank you, one and all.
Thank you very much, sir, for a wonderful presentation. I will take up the questions from the participants now, sir.
Yeah, okay.
The first question is, how do value addition processes for agricultural residues impact the economic viability of farming practices?
Repeat the question, madam. How do value addition of?
How do value addition processes for agricultural residues impact the economic viability of farming practices?
Actually, question should be limited to value addition of agro residues. If any question is pertaining to that, I can answer.
Okay, I'll take up the next.
If any question is related to plain agriculture,
Okay,
I will not answer those questions. This
question
is only for value
I'll move on
addition
to
of
the
agro
next
residue.
one, sir. I'll move on to the next one. Are there any challenges or limitations associated with the value addition of cotton biomass and agricultural residues?
Yeah, this is very good question, madam. I will tell what are the challenges here. The challenge is that, okay, am I audible?
Yes, sir, you are audible. Please proceed.
Okay, the first and foremost challenge is that cotton stalks remains in the field after harvesting of the cotton, raw cotton. Unlike other crop like soybean, rice, these things are harvested. Biomass is also harvested along with the grain material. So once it is available in the field, it is required around 1,500 rupees per acre for uprooting the material. After uprooting, it has to be, farmers are normally burning it. So for viable collection of this material, it is required to create a complete value chain. Value chain means the existing practice is that farmer will uproot it and burn in the field. But if farmer has to supply it to some unit for value addition, farmer has to provide some infrastructure facility. It is available for 2 to 3 months duration. If I talk about Maharashtra and Telangana, it is available only January, February, March period. After March, there won't be any biomass, cotton biomass in the field. So there is requirement of around one chipper, 2 tractor trolley, and 2 tractors for collection of biomasses from 1,000 acre of land. That is available mostly in one village. So for that, 2 tractors require 30 lakh rupees, 2 trolley require 5 lakh rupees, and one chipper require 2.5 lakh rupees. So around 45 lakh rupees investment is required. For that, farmer is not capable and not required also, because farmers, if they are doing it, will require high cost investment, and it can be used only for 2 to 3 months time. So what government has to do is that government has to promote custom hiring center. We at CERCOT has established a custom hiring center where we are supplying shipping machine to the farmer groups, and we are educating the farmers for supply of biomasses using our chipper machine, and we are connecting farmer with the industrialist. So you collect the material, supply to the industry, so that we both will be in the win-win situation. So these are the issues, madam. These are the issues means one has to initiate the process and government has to help. Then otherwise industry has to come out. One good thing I would like to tell you. This year, our institute have received 15 machines from one industry. They have given it to us for distribution to the farmers. We have given it to the farmers. Now farmers have entered into MU for supply of the material, and it is working well. I think I
Yes,
have
sir. Yes, sir.
your
I will
question.
take up the next question, sir.
Uh,
How can policymakers support the adoption of value addition techniques for agricultural residues?
no, currently, what are the schemes available that I will highlight? So the government of India is promoting value addition of agro residues to the fullest extent. They have come out with the policy also where they have made it mandatory for all power generation unit to use 5% of biomasses. And now they have made it mandatory almost for each and every power generation unit to purchase it from the market. And second thing, for establishing of any briquetting and pelleting plant, Government of India, Ministry of Power is giving subsidy also, cash subsidy also, and it is also being promoted by state governments. Particularly, Government of Maharashtra is giving 90% subsidy for establishment of briquetting and pelleting plant. So similar type of initiatives are required from all the stakeholders and governments.
Okay. Sir, are there any innovative or emerging methods for value addition to cotton biomass and agricultural residues that show promise?
No, there are actually presently only 2 ways are used for collection of cotton stock biomass. One way is that you approve that. I have not covered that thing here. I wanted to show the industrial point of view, that how industry function and what are the investment required for the industry. For the supply of biomass, one has to follow the appropriate logistic. Appropriate logistic means first material has to be uprooted using B-pass machine. Once it is uprooted, means it should be allowed for 1 week time for drying. After drying, it has to be collected and it has to be shredded in the field condition in the field itself using the cotton stock chipper by 2 tractors and 2 trolley, one chipper machine. This is the one logistic. Another logistic is that one Shaktiman type of shredder is available in the market, where it cuts the biomass from at around 5 inches sizes, 5 inches from the root of the plant, and the biomass will be chipped and it will be collected in a trolley. These two systems are only prevalent, and there is no other technology available for supply of these biomass, cotton stalk biomass to industry.
Okay, I'll move on to the next question, sir. How does value addition to agricultural residues contribute to the circular economy and reduce waste in agricultural sector?
Now, circular economy has several meanings. If I say here that how the value addition, if the way I am suggesting you, the preparation of briquettes and pellets. So how we are promoting circular economy using our technology, we are suggesting that make briquettes and pellets out of cotton stalks or any other agro residue which is available in the market. Once it is utilized in the power plant unit, it can be used for making the fertilizers. After it is converted into fertilizer or composting purpose, it can be used for enriching of our soil. That will increase the circularity of economy.
Okay, sir. I'll move on to the next question. How can farmers be educated and trained to adopt value addition practices for their agricultural residues effectively?
Now, farmers, actually, we are telling that how farmers need to be educated. I worked many years in the field. I know farmers are more educated than scientists working in the lab. Only thing what needs to be done is that farmer has to be provided infrastructure for collection of the material. Infrastructure means they have to be supported financially.
Okay, sir. I'll move on to the next question. Sir, is it possible to tell any success case stories or example of businesses or initiatives focused on value addition to cotton, biomass, and agricultural residues?
The success story is in Maharashtra, we can say. If somebody coming to Nagpur and nearby area, where Sircot has presence in the form of Genie Training Center, we have actually given our 5 chipper machine to 5 group of the farmers. They collected every year 5,000 tons of this cotton stock and supplied to one briquetting plant. And they earned, even farmer groups also earned significantly, as well as this briquetting plant owners also earned significantly. And now this story I am telling 3 years ago. Presently, there are around 4 or 5 pelleting plants and briquetting plant in and around Nagpur area. They are giving machines to individual group of the farmers, and they are collecting material on buyback basis. And many persons, they are telling that now you bring the material, weigh it on our beverage, and immediately after weighing, we will transfer the money to your account. There is requirement wherever briquetting plant is there, they will definitely purchase it, provided it is supplied to them at the cost of rupees around 3,000 per ton. And for that, it is not possible for individual farmers. What I say that the logistics suggests that if somebody is taking up this activity, this should be taken by a group of the farmer where their minimum target is 1,000 area collection as well as supply of 6,000 ton of the material. Okay, next question, madam.